The previous session explained how the file or files that make up the part program can be set up into a job. This session explains some other settings that affect how the part program manipulates the machine. The location of the work within the operational area of the machine is another essential setup that may change from job to job. The positioning information contained within the part program always refers to a frame of reference called a fixture offset. The fixture offsets settings allow you to offset the script's dimensional frame of reference from the machine's home position. G-code controller supports up to 6 frames of reference, which can be changed within the G-code script using G54, G55, G56, up to G59. The default frame of reference is G54. The Fixture Offsets dialog displays the stages that you set up as active in the system configuration. You can type the offset values for the stages into the respective fields. Alternatively, you can automatically apply the current position of each stage. Notice that manual positioning dialogs are available. You can apply the current position of each stage individually, as you might, for example, in a procedure to touch off the tool on the sides and top of a rectangular block. In this demo, a positioning block automatically arrests joystick motion at the fixture offset position, which can be automatically read into the Fixture Offsets dialog using the associated control button. The All button applies the current position of all stages at once in cases where that might be more convenient. Automatic operation can be made to commence using one of 2 methods, run or dry run. The dynamics of motion for each of these methods, explained more fully in Part 7 of the series entitled Contouring, is set up in the Default Feed Rates dialog. The dry run operation is often used to check the integrity of the tool path and assure clearance from things such as clamps. The dry run rates are often set higher than the production run rates in the interest of saving time. An F command within the G-code script can be used to change the feed rate during the run operation. The F command has no effect on the feed rate during a dry run operation. The feed rate override control can be selectively applied to rapid traverse and vector feed rates using this dialog. Since the dry run operation is generally used to check for tool collision, you would typically want to be able to manually control the speed of the tool during both rapid traverse and feed cutting paths. During a production run operation, however, the feed rate override is typically used only to adjust cutting speeds. However, in some production settings, it may be important to keep the feed rate override control from accidentally changing a cutting speed that had been previously determined. Leaving both feed and rapid traverse checkboxes unchecked accomplishes this purpose. The Contour Tool Feed feature, also explained more fully in Part 7 of this series, is generally enabled. Disabling this feature allows you to advance the motion under control of the part program in finer increments for troubleshooting purposes. The positioning mode determines how positioning numbers in the G-code script will be interpreted. Positioning mode can be changed within the G-code script by G90 and G91 commands. Absolute mode, instantiated in the G-code script by G90, interprets positioning numbers as distances from the fixture offset position. Incremental mode, instantiated by G91, interprets the numbers as distances from the current tool location. This dialog sets the default positioning mode. Snapping over the G02, G03 menu brings up the ARC translation dialog. The center point location group specifies how the center point locations for ARC interpolation will be interpreted from the G-code script. The always incremental setting is the most common and similar to Fanuc controllers. Some older controllers interpret the center point location arguments as absolute positions. Some other controllers interpret these locations according to the current positioning mode within the G-code script. If the mode was absolute, instantiated by G90, then the center point values would be interpreted as absolute locations. If incremental, instantiated by G91, the center points would be interpreted as distances from the current position. This group allows you to set up G-code controller to emulate these different types of controllers. The always incremental setting, however, is recommended. Arcs are approximated using multiple straight line segments called facets. Segment error is the maximum distance between the facet and the true theoretical arc. For a given segment angle, segment error becomes more pronounced with larger radii arcs. In most cases, a given segment error is less tolerable for smaller radii arcs than larger ones. In order to accommodate the greatest range of large and small arcs in a single job, G-code controller uses the following strategy. Arcs are generated in segments subtending the setup value for segment angle. However, if the radius of the arc is sufficiently large, the arc will be divided into sufficiently small segment angles so that the setup value for segment error will not be exceeded. The maximum segments per arc field guards against extreme proliferation of segments. Arcs are subtended along the current reference plane, instantiated by G17 for the plane in XY, G18 for the plane in XZ, or G19 for the plane in YZ. This toolpath demonstrates arcs subtended in these three planes. Also, the stage normal to the reference plane will be the drill stage for the canned G-code cycles. This dialog establishes the default reference plane. If the skip block feature is enabled using this menu, then any line or block within the part program that begins with a front slash character will be ignored. In this example, 3 canned drilling procedures are performed at 1-inch intervals. With block skip off, all 3 operations are performed. With block skip on, the block with the front slash character is ignored and only 2 holes are drilled. The Tool Offset Table menu provides for length and radius offset compensation for up to 100 tools. The spin buttons are used to select the tool that you wish to size. The diameter of the tool can be entered into the D field. The length of the tool can be entered in the H field. The value for tool length compensation can be conveniently determined using the H calculator's Apply button. You can use manual positioning controls to touch off each tool on the drill stage's fixed or offset position. When you snap Apply, the relative offset for that tool will be automatically entered into its H field. In some production settings, it may be convenient to keep collections of tools preloaded in collets and sized. For this reason, you can optionally save and retrieve a collection of H and D offsets to a separate file. When the job is loaded, then, the values saved under that file will be automatically loaded. As mentioned, most of the settings accessible from the job menu will not have to change from job to job. Sometimes only the file name or names of the part program will need to be changed. All of the settings, nevertheless, can be saved together under a unique file name using File, Save As. Or, changes can be used immediately to run the job, which is the topic of our next session entitled Automatic Operation.